Good morning, students. So we were discussing about Terzaghi's bearing capacity theory, and the Terzaghi's bearing capacity equation for a strip footing is like this. That is QU, ultimate bearing capacity QU is equal to CNC plus QNQ plus 0.5 gamma B n gamma. C is the cohesion. Then Q is equal to gamma into dF. That is unit weight of the soil into depth of footing. That is surcharge component Q. And B is the width of footing, and NC, NQ, N gamma are the bearing capacity factors, and this depends upon phi value only, that is angle of shear. Based on the value of angle of shear resistance phi, NC, NQ, N gamma varies. That is, this NC, NQ, N gamma depends only on the value of phi. Okay, and this NC is the contribution of cohesion. This is the NC's contribution of cohesion, and NQ is contribution of surcharge, and N gamma is the unit weight of the soil, contribution of unit weight of the soil to the ultimate bearing capacity. So in this equation there is three component. First one, contribution of cohesion, then contribution of surcharge, and contribution of unit weight of the soil to the ultimate bearing capacity. Okay, so this is cohesion, then surcharge, unit weight. This is the bearing capacity equation for a strip footing. Next, in this equation there are some subdivision, that is approximation for QU. That is, if C is equal to 0, C means cohesion, if the value of cohesion is 0 and Q is equal to 0, Q 0 when dF, depth of footing, if we are calculating the bearing capacity at the ground level, depth of footing will be equal to 0. Okay, at that case Q is equal to gamma dF, so Q will be also 0. So in that equation, what will be the equation of QU? Q is equal to CNC plus QNQ. So that two terms will be equal to 0. So last term will be there, that is 0.5 gamma B n gamma. Okay, this last term is independent of depth of footing and cohesion. So if C is equal to 0 and Q is equal to 0, in the equation of ultimate bearing capacity, last term will be there. Okay, the other two terms will be 0. So QU is equal to 0.5 gamma B n gamma. And another case, if gamma is equal to 0, that is unit weight of the soil is 0, that means it will be a weightless soil. And at that case Q is equal to 0, Q is equal to gamma dF, so Q is also 0. So the last two terms will be equal to 0, because in the second term Q comes and third term gamma comes. So first term Q is equal to CNC will only be there. So QU is equal to CNC. Like that, if gamma equal to 0 and C is equal to 0, that is unit weight 0 and cohesion 0, at that case QU is equal to first term will be 0, so CNC plus QNQ, that is second term only will be there. Okay, like that. So these are the some special cases. So in the problem, if it is asked for calculating ultimate bearing capacity for cohesionless soil, at that case you substitute C is equal to 0. Okay, like that. So basically you study this equation, and problem will be asked based on this equation, and this equation is for strip footing only. And for other types of footing, that is for square footing and circular footing, I have explained the equation. That is, for square footing QU is equal to 1.3 CNC plus QNQ plus 0.4 gamma B n gamma. Okay, and for circular footing QU is equal to 1.3 CNC plus QNQ plus 0.3 gamma B n gamma. Here B will be diameter, or you can write 0.3 gamma D n gamma. Okay, so you by heart this equation, and if it is circular footing, this will be diameter, and for square footing it will be side of one side, that is width. Okay, so that is the equation for square and circular footing. And for rectangular footing there will be width B and length L. Okay, so for that equation is QU is equal to CNC into 1 plus 0.2 B by L plus QNQ plus 0.5 gamma B n gamma into 1 minus 0.2 B by L. So the equation is same as that of strip footing, but in the first and last term there comes this parameter, that is 1 plus 0.2 B by L in the first term and 1 minus 0.2 B by L in the last term. Okay, so for rectangular and strip footing equation is the constants in the equations are same. That is, in first term it is constant 1 and last term 0.5, same as strip footing. But the change is for rectangular, since B and L are varying, the term this term will come in the first and last term. Okay, that is 1 plus 0.2 B by L, and here 1 minus 0.2 B by L. So these are the equation of bearing capacity for different types of footing. Okay. And up to this we have studied about general shear failure, that is Terzaghi has derived the equation for general shear failure condition, and if the shear failure is local, at that case the mobilized cohesion and mobilized angle of shearing resistance, that is mobilized cohesion C dash is equal to 2 by 3 into C. Okay, so if C is given, you substitute, you multiply it with 2 by 3 and it will result into mobilized cohesion, and substitute this value in this equation. Okay, and mobilized angular shear resistance tan phi dash is equal to 2 by 3 tan phi. So based on this mobilized angular shear resistance, NC dash, NQ dash and N gamma dash have to be calculated or noted down from the table and substitute in the equation. Okay, so you can do one problem. Determine the ultimate bearing capacity of a strip footing 1.2 meter wide and having the depth of foundation of 1 meter. Use Terzaghi's theory and assume general shear failure. Take phi is equal to 35 degree, gamma 18 kilonewton per meter cube and C 15 kilonewton per meter square. Okay, so here it is asked to find out the ultimate bearing capacity, that is QU, for a strip footing. So first you write down the equation for ultimate bearing capacity in the case of strip footing, that is QU is equal to CNC plus QNQ plus 0.5 gamma B N gamma. Q means gamma df, that is CNC plus gamma df into NQ plus 0.5 gamma B N gamma. And here we have to calculate NC, NQ and N gamma, and I have told that this NC, NQ, N gamma varies with phi, and the table is like this, that is for different values of angular shear resistance phi. So here it is phi dash and it is same as phi in some problem, that is here they have given it as phi dash or it is C dash. So it is given that it is general shear failure, so don't get confused with our local shear failure phi dash. Okay, notations are varying in different textbook, that's why here it is phi dash and C dash. And for phi, here angular shear resistance phi is 35 degree. So for 35 degree, what is the value of, that is for 35 degree, note down the values of NC, NQ and N gamma, that is 57.8, 41.4 and 42.4. sorry, that is it is clear from so it is sorry, the value is clear from this table, that is for phi is equal to 35 degree, these are the values of NC, NQ and N gamma. So write down that values and substitute this in the equation, that is C is given as 15. Okay, so 15, then NC is obtained as 57.8 from the table, plus gamma is 18, depth of footing is 1 meter, depth of foundation is 1 meter 1, then NQ 41.4 plus 0.5 gamma 18, B width is given as 1.2 and N gamma 42.4. so the answer is 2070 kilonewton per meter square. Okay, so here you should by heart this equation. The problem in this area is very simple. It will be asked for calculating ultimate bearing capacity or safe bearing capacity, etc. Okay, so here it is the table, and in this table general shear failure values, for general shear failure values of NC and NQ and gamma is given, and for local shear failure, if it is local shear failure, you find out the value from this section. Okay, in university exam mostly the values will be given NC, NQ and N gamma. If it is not given, they will give provide the table. Okay, so you don't need to by heart this value, but for phi is equal to 0 you have to by heart this value. I have explained that in last lecture, that is for phi is equal to 0, NC 5.7, NQ1 and N gamma is 0. You should by heart this value only. Okay, next problem, determine allowable gross load on and the net allowable load for a square footing of 2 meter side and width of and depth of foundation 1 meter. Use Terzaghi's theory and assume local shear failure. Take factor of safety 3 and soil parameters gamma is given, C is given and phi angular shear resistance 25 degree. Okay, here they have given that it's local shear failure condition. Okay, that is here phi dash is equal to 25 degree, phi is 25. So for 25 you have to find the values from this section, that is it is given as local shear failure. So phi is equal to 25 degree, NC, NQ and N gamma is 14.8, 5.6 and 3.2. Okay, so you first write down these values and write down the equation. It is for square footing. So what is the equation? 1.3 CNC. So here it is 1.2. In some textbook it is 1.2 and some it is 1.3. So no problem. And here it is 0.4. And is 1.2 CNC plus QNQ plus 0.4 gamma B and gamma. Okay. And here we have to find out mobilized quotient, that is 2 by 3 into this quotient value. Quotient value here it is given as 15, so 2 by 3 into 15, 10. Okay, so we got all the values and directly substitute in this equation, and we will get the ultimate bearing capacity as 325 kilonewton per meter square. Here it is asked to find allowable gross load and net allowable load. That is, first we have calculated ultimate bearing capacity QU, and it is obtained as 325 kilonewton per meter square. So the ultimate bearing capacity equation for square footing is 1.2 CNC plus QNQ plus 0.4 gamma B and gamma. Okay, and net QU, it is QU is 325 and QNU is equal to QU minus gamma DF. Okay, that you have studied in the first lecture. That is the some definitions, bearing capacity equation definitions. That is QU ultimate bearing capacity, the net ultimate bearing capacity QNU is equal to QU minus gamma DF. So substitute the values, we will get 307. Okay, then QNS net safe bearing capacity is equal to QNU divided by factor of safety, and here factor of safety is given as 3. So QNS is equal to 102.3 kilonewton per meter square, and net allowable load is equal to this QNS into area. Okay, that is capital Q. Capital Q is equal to small letter q into area, that is 102.3 into, since it is square, 2 by 2, 2 into 2. So that is the answer. Net allowable load, here it is asked to find out net allowable load. Okay, then also asked to calculate allowable gross load. So if we want to calculate the gross load, gross allowable load, that is QS is equal to QNS plus gamma DF. We have to add the surcharge component, that is QNS, here it is calculated 1.2 plus gamma DF, that is QS. So gross allowable load, if you want to calculate gross allowable load, this QS into area, that is QS 120, here it is calculated 120 into area, since it is square, 2 by 2, that is 481. Okay, so this is the procedure. So in the previous problem it is asked to find out the ultimate bearing capacity only. Okay, so but here it is not asked to find out the bearing capacity, here it is asked to find out the load. So we have to multiply the bearing capacity value with the area. Okay, so if they ask to calculate net allowable load, you find out QNS, that is net safe bearing capacity, and multiply it with the area. And if you want to find out gross allowable load, calculate the gross load, that is QS, then QS into area, that is the gross allowable load. So this is the procedure. So in the next class we can discuss about the effect of water table on bearing capacity. So thank you.